Good afternoon, everybody, and welcome to our next session at PyCon 2017. Before we start, I would very much like to encourage everybody to take out their phones and any other electronic device that is capable of making noise and make sure that it probably won't, because when it does, everyone will look at you and you're going to feel very silly. With that out of the way, I would like to introduce our next speaker. It's Jon Banafato, who is going to talk about what's in our pip toolboxes. Please make him welcome.
Hey everybody, my name's Jon Banafato. I work at iHeartRadio, where we have a lot of code written in Python. I also organize Python community events in New York, including NYC Python, the Learn Python NYC meetup group, and PyGotham, which is coming this October. Today I want to talk a little bit about dependency management. We're going to start off with a brief introduction to pip. We'll move on to a better way to manage your requirements files. Finally, we're going to talk about some other tools related to pip and the Python package index. But first, a couple of prerequisites. Before we care about dependencies, we need an application. So here we have a framing device. It's a trivial, contrived microservice we need to install dependencies for. This is a Flask application that translates Unicode to ASCII. So now we run the app using the Flask CLI. We have a working microservice that successfully converts the string Motorhead to its ASCII equivalent. So how are we going to install the dependencies necessary to run this thing? First approach, I'm going to SSH into my server. This is my live production server. I'm going to install some things through apt-get and through pip, using sudo, of course. And I'm going to use the Flask CLI to run it. 2 simple commands, and we're done. Thanks, everybody. Enjoy the rest of the conference. No, of course, that's not how we're going to do this. So briefly, before we move on, I'm going to assume everyone in the room is using virtualenv or some equivalent. You should always use virtualenv to isolate your environment from others on your system, including the system environment. virtualenv is out of scope of this talk, though, so we're going to move on. If anyone has questions about that, we can talk about it afterward. So to install all of the dependencies needed to run our app, we're going to use pip. Pip is the de facto standard Python package manager. It does all the things you would expect a package manager to do, so it installs, upgrades, uninstalls all of your dependencies. Typically, we define these dependencies in a file called requirements.txt and use pip install -r to install them. This is the conventional way to manage Python dependencies. So we'll install all of our things, run pip freeze, dump that into a requirements.txt file, and call it a day. So any questions about pip or requirements.txt so far? Great, moving on. Please don't do this. This is the wrong way to approach dependency management in Python, and to understand why this is wrong, we have to take a look at the purpose of requirements.txt. These files communicate dependencies to both machines and to people, and we really tend to forget about people in this context. These are totally separate concerns. Machines need dependencies specified to install them. More specific, the better. People care about why dependencies exist. We need to know what's actually being used by the applications, not every dependency all the way down the stack. Our previous example only addressed the machine aspect of this, and it still has problems. So here's what we actually got when we generated that requirements file using pip freeze. There's a bunch of extra stuff in this environment that's not part of my application. And I actually had to cut this off after a while because it didn't fit on the slide anymore. This adds problems for both use cases. For the machine use case, this includes our development environment. So if you notice, I'll have dependencies like flake8 and bpython in there. It makes it difficult to update individual requirements. So if I want to upgrade Flask, I need to know whether All of its dependencies need upgrades as well. And it also doesn't handle no longer needed dependencies. So if I depend on a library that depends on 6, which is a Python library for dealing with Python 2 to 3 translation, eventually Python 2 support's going to go away from that library. I won't need 6 anymore, but it will forever live on in my requirements.txt. Additionally, when we're talking about the people aspect of these files, this doesn't tell us what a developer meant to install. This is just what the end result was. And we don't know where a lot of the things in this file came from. And we'll talk more about that later. So a better way to do this is to maintain 2 sets of dependencies, one for people and one for machines. This solves the problem of conflating 2 different concerns in one file, but it can be tedious. Right? We have 2 different requirements files to manage by hand now. We're going to explore ways to fix that. So in our application, we only ever depend on Flask and Unity code. That's all that has to be in my requirements file meant for people. We'll still use the other requirements.txt from the previous slide for machines. So to jumpstart this requirements file, we're going to use a tool called piprex. This is a great way to bootstrap your application's dependencies. When you run it, it scans your project for imports and saves the dependencies to requirements.txt. This is really useful when you're starting off a fresh project. As the project matures, you'll probably want to move to a more manual approach, though. This allows you to avoid overwriting your existing requirements every time you update a new one. One caveat here, though, is piprex will not generate requirements that aren't explicitly imported by your application. So if you're using something that depends on PsychoPG2, for example, to talk to a Postgres database, this won't pick that up. Still, it's a better approach to separate our concerns of people requirements and machine requirements. So now we have 2 files to update and maintain, which is not fun as a manual process. Here we have our requirements file for people at the beginning, and then the later one is for machines. There's a better way to handle this, though. Pipcompile is a command line utility provided by a library called piptools. This allows you to explicitly manage dependencies for people in a file we call requirements.in. We'll use that to generate our machine dependencies, which will still be called requirements.txt. This combined approach satisfies both of our concerns here. Developers only need to care about what's consciously specified as a dependency in requirements.in, and pipcompile generates a file for us used with machines. So here's the output of that. This is really similar to our original requirements.txt file with a few differences. One, this is managed by code, and we never have to go in here and edit it by hand. 2, it still includes only what we want. So I don't have any of my development environment libraries in here. I don't have testing libraries. It's just what the application needs to run. 3, and it stays out of our way. I, as a developer, I'm going to deal with requirements.in and generally not look at this unless I'm trying to debug something with it. So this is pinned all the way down for our machines. It's annotated so we know where our requirements came from. I want to talk briefly about a project called pipfile. This is a new project that's under active development. Keep an eye on it going forward. I'm not going to show any examples here because they may quickly become outdated. But this may eventually become the officially recommended tool by the Python Packaging Authority in the future. It's inspired by other package managers like Bundler and NPM. And if you want to get started with it today, check out pipenv, which is a tool that sits on top of pipfile and virtualenv to combine their concerns and manage all of your application's dependencies for you. So now that we have all of our dependencies managed properly, we want to stay on top of updates. There are a few ways to do this. Pip provides a way to list outdated packages in your local environment. For a quick check on the web, there's a tool called version check. If you go to therealkd.net/version check, you can paste a requirements file there, and it will tell you what needs to be updated. If you're using GitHub or Bitbucket, projects like requires.io and pyup.io monitor your Git dependencies and notify you of updates to your requirements. These are both proprietary services, but they do have free plans for open source projects. So we did it, everybody. Now we have a way to manage all of our dependencies for both humans and machines. We're set up to handle updates. And the best part is we pinned everything so it's all reproducible, right? Not quite. This isn't necessarily reproducible or safe. When everything is working properly, this should be totally fine. This may fail, though. If we have corrupted downloads or even a malicious attack, we may get the wrong code that we're trying to install. So to account for this, we'll use hash checking mode. Originally provided by PEEP, PIP got hash checking support in 8.0. This ensures that all of the files you're installing are the same files that were used to generate your hashes, which is to say it's a step toward reproducibility. This is really highly recommended, and there's not much downside to it. Pip compile supports this with the generate hashes flag, with the caveat that these are platform specific. Hashin will generate hashes for all of your dependencies on every platform available. Definitely do this. It's going to make sure that your applications are a lot safer when you install dependencies. So when we install this through our new requirements.txt, with hashes specified, the entire operation is going to fail if any of the hashes don't match. So now we can be sure that our installs are totally reproducible as long as the install works. So that's the end of my section on dependency management. Now we're going to talk a bit about a few other tools to work with pip and the package index. So when we want to explore an environment, for instance, if you've fallen into an environment that was managed by pip freeze into a requirements.txt file, we can use a command called pip-deptree. So this allows you to generate a dependency graph of what's currently installed in your environment, and is really useful for working with existing applications where dependencies may not be totally kept up to date. Even more useful is the reverse flag. This answers the question, why is this thing installed? This flips around the output so that the leaf packages are showed first, and it allows us to go back to that requirements.txt file that I showed at the beginning and figure out how some of those dependencies got installed into my environment. So now I can look and see that, missed a slide. Another tool that's really useful is pipsy. Pipsy manages Python CLI scripts and keeps your system environment clean. This uses virtualenv under the hood. It's somewhat easy to replicate, but it's really convenient if you're going to install things like bpython or even pipsy itself. It also supports keeping all of these CLI scripts up to date and separate from other virtualenvs on your system. There's another tool called leak, which gives us really useful metadata about our packages on the Python package index. This gives us information about the author, how popular each individual release is, how often releases happen. It's very useful when you're deciding what versions to use, how active a release schedule is, et cetera. It's great for fetching package info without leaving your terminal. So before we end, I want to say that this doesn't apply to just Python. You should take this approach with all of your development, and you'll avoid a lot of headaches later. I have links to all of the tools I mentioned in the upcoming slides, and these slides will be posted online as well. If anyone knows other tools for improved dependency management, please let me know. I'm always looking to improve my development process. So thanks for coming to my talk. I hope these tools help make your dependency management safer, more secure, and easier. And are there any questions?
Thank you, John. If you have questions, please move to the microphones that are in the aisles. Starting over here.
Hey, you mentioned pinning hashes in your dependencies, which seems like a pretty good idea. I noticed those are like SHA-256 hashes. Where do you get a canonical hash that you can actually trust to have some confidence that you're putting a good hash in if you're actually using hashes to gain confidence you don't have the wrong binaries?
Right, so typically you would use a tool like pipcompile or hashin to generate your hashes. That said, I think that's probably not what you're asking about. That generates the hashes based on what you're installing right now, but not canonical hashes provided by developers, for example. I don't have a great answer for that right now, but it would be really useful if developers did publish hashes for their packages. Yeah.
Yeah, or potentially PyPy saying what hash it originally got for a version or something.
Absolutely.
Yeah, I was wondering if you have any strategies for maintaining your requirements list both from requirements.txt and in setup.py, because you know, doing a lot of reading. It's an anti-pattern to parse requirements.txt from setup.py. But if you have a lot of dependencies for a big project, maintaining those two lists by hand is pretty troublesome.
Sure, so the question is about maintaining both requirements.txt and a setup.py file and reading in the former from the latter.
Well, yeah, just what's the best, or what is a good pattern to keep those in agreement without having to do it by hand?
There's been a lot of discussion about this on the web. I think the best short answer is generally use setup.py with looser requirements specified for libraries and requirements.txt with exact requirements specified for applications. That said, there are always going to be corner cases where you're providing something that is an application but also meant to run in slightly different environments. There's no real concrete answer for always do this, but generally, if you're able to control the exact environment under which your application runs, pin everything in requirements.txt. If you can't, and it's a library, make that a bit looser and only pin where necessary. And whether you read that into your setup.py or not is really up to you.
Thanks.
Do you recommend using pipcompile manually whenever you feel like it, or as an automated step during deployment?
So pipcompile to generate your requirements.txt file should always be run by a developer, right? This is when you're installing a new dependency to your application. So for instance, I add Unity code to my requirements.in file. I'm going to run pipcompile and generate a new version of my requirements.txt. The automatic steps later on are going to be to build the virtual env or whatever other environment it's running in.
Got it. Thanks.
Are there any other questions? Yes.
Hi. One thing I've noticed with requirements text files is if one line has a specific version requirement and then a later line has a conflicting version requirement for the same package, the last one just wins. I was wondering if you had any recommendations for getting around that dependency resolving.
Sure. With modern versions of pip, that should outright fail. Pip should refuse to install any set of requirements that includes multiple conflicting versions, but pip doesn't currently have a dependency resolver. If you were in the certbot talk earlier, they talked a bit about this. There's an open issue that's a few years old now on the pip project to add a dependency resolver, but in short, there's no great solution for that right now. There are alternative package managers, but in general, try to keep your sets of requirements small for anything you're deploying so that you're not having those conflicting situations.
Are there any more questions? Thank you very much, John.
Thanks, everyone. Before we care about dependencies, we need an application. So here we have a framing device. It's a trivial, contrived microservice we need to install dependencies for. This is a Flask application that translates Unicode to ASCII. So now we run the app using the Flask CLI. We have a working microservice that successfully and Pygotham, which is coming this October. Today I want to talk a little bit about dependency management. We're going to start off with a brief introduction to pip. We'll move on to a better way to manage your requirements files. Finally, we're going to talk about some other tools related to pip and the Python package index. But first, a couple of prerequisites. It converts the string motorhead to its ASCII equivalent. So how are we going to install the dependencies necessary to run this thing? First approach, I'm going to SSH into my server. This is my live production server. I'm going to install some things through apt-get and through pip, using sudo, of course. And I'm going to use the Flask CLI to run it. Too simple.
Banafato, who is going to talk about what's in our pip toolboxes. Please make him welcome.
Hey everybody, my name's Jon Banafato. I work at iHeartRadio, where we have a lot of code written in Python. I also organize Python community events in New York, including NYC Python, the Learn Python NYC meetup group.
Good afternoon, everybody, and welcome to our next session at PyCon 2017. Before we start, I would very much like to encourage everybody to take out their phones and any other electronic device that is capable of making noise and make sure that it probably won't. Because when it does, everyone will look at you and you're going to feel very silly. With that out of the way, I would like to introduce our next speaker. It's Jon Banafato.